Okay, so today we're going to start talking about multiplying and factoring. So, you know how I kind of got really super excited on Tuesday about Chapter 8, and I was like, I love Chapter 8! Remember that? Okay, I do. I love Chapter 8. And the big thing I love about Chapter 8 is the factoring part, which starts in the second half of Chapter 8. I like the first part of Chapter 8, but the second half of Chapter 8, love it. Okay, that's the factoring part. So we're going to kind of introduce factoring today and just do like the very first part of factoring, and then we'll come back to it in section 8.5. So factoring, you guys kind of did factoring on your Get Ready assignment, but I think actually only 2 of you did. But besides that, okay, so on your Get Ready assignment that we graded on Tuesday, one of the things that you were doing is that find all the factors of the number. And so like if it started with 12, you were looking for all the numbers that you could multiply together to give you 12. So we could have used like 3 and 4, because 3 times 4 gives me 12. 3 and 4 are factors of 12. So when you hear factor, we're not going to be looking for factors of numbers today. We're going to be looking for factors of polynomials. But it's still the same thing. What can you multiply to give you this polynomial? Okay? Now, when you multiply them, you get that number. So the first thing we're going to do, because math is a lot about inverse operations, we're going to start first on the multiplying half of it. Okay, so we're going to talk about how to multiply polynomials, and then we're going to turn around and do the opposite and learn how to factor numbers, turn them into a multiplication problem. So, how to multiply polynomials, we're going to kind of do 3 different sections on multiplying polynomials, and the first one's going to be today. So this is the simplest way to multiply polynomials, and that's by using the distributive property. And it's simple because we already know how to use the distributive property. We do the distributive property all the time. Now, usually whenever we do the distributive property, it might be like this first one here, but it might just say 3. In the past, that's all it's been. It's like 3 times x minus 4. The only difference today is it might say like 3x times x minus 4. So what it changes is we're going to have to use those exponent rules from the last section. So I saw this and I thought it was kind of cute. So use the distributive property, rules of exponents to multiply. You're going to create a rainbow. So you might know what I'm talking about whenever I say that, because whenever I want to multiply 3x times x minus 4, you're going to distribute the 3x. And so a lot of times what we do is we draw those little arches. We create a rainbow. Yeah? Cute? No? No personality today. Yeah. Okay, so 3x times x. Once again, think about the properties of exponents. Now, yesterday, I drilled it in your brain yesterday. When you're adding or subtracting like terms, the variable part does not change, which is so true. But we're not adding and subtracting here, we're multiplying. I'm taking 3x times x. When you take x times x, you get x squared. So 3x times x gives me 3x squared. When you're multiplying, the variable part does change. That's what we did all last chapter. Okay? And then we have to have another little arch of our rainbow, and I would take 3x times negative 4. 3, and I like to kind of do this in pieces. 3 times negative 4 is negative 12, and then we still have that x. So we just throw that x down there. Okay? And then they just kind of get just a little bit trickier. So it's the same thing. You're going to distribute, and you're going to do that by multiplying. So you're going to take 2x squared y times 3x squared. Now, take this in pieces. So when you multiply these two things together, we did this last chapter, you have to multiply the things that you can multiply together. So when I take 2x squared y times 3x, I can multiply the 2 times the 3 because they're just numbers. So when I take 2 times 3, I get 6. I can multiply the x's because they have the same base. So you have x squared times another x squared, which gives you x to the 4th. And then you just have that y. So just take it in pieces, okay? Then you're going to turn around and you're going to distribute the 2x squared y to the negative 7x. So, start with the numbers. 2 times negative 7 is a negative 14. Okay, for the x's, I can multiply those together. So I have this x squared, and I have this x. X squared times x, see it? Be an x cubed. And then you have that y there still from the outside. And then the last little arch of our rainbow here, we would take 2x squared y times 1. I did this a lot yesterday. What happens when you multiply by 1? So I say nothing. Just going to say plus 2x squared y. Okay, and then the last one here on this example, just be careful here because whenever you're distributing here, we're distributing a negative x squared y cubed. So make sure when you multiply those, you're taking the negative with it. So here, if you liked what we did yesterday, if you want to put a little 1 there, that might help. Because you're going to take negative 1 times 8, which is negative 8. We're going to take x squared times x squared, which is x to the 4th. And then we have y cubed. There's no other y cubed, so it'll just stay y cubed. Then we're going to distribute here. Do your numbers. Negative 1 times a negative 5 will give you a positive 5. X squared times this x, x squared, and then another x will give you x cubed. Now we have y cubed and a y. Y cubed and a y would give you a y to the 4th. And then lastly, negative 1. Do the numbers first. Negative 1 times negative 2 would give you a plus 2. X squared. There's no other x's to add to that, so it's just going to stay an x squared. But then I have y cubed, and I have a y squared. So that would give me a y to the 5th. That's half of what we're doing today. Okay? Now, I want you to go ahead and take this piece of paper. You can go ahead and just chop off the bottom. You don't need that. So you can chop off the factored version, leave factored version and distributed version, but you don't need what's underneath there. Would have, if we would have been doing this all in one day, but because of time, we won't worry about that. So you can just chop that off. We're not going to use it, so you can throw it away. Okay, now, well, this part is this is going the other direction, so we just multiply. We multiply by using the distributive property. Okay? If you want to go back the other way, it's called factoring. Now remember, whenever I said you're looking for factors of 12, you're looking for what can I multiply to give me 12? It's the same thing with polynomials. What can you multiply together to give you this polynomial? Now we're going to learn so many super incredibly fun ways to factor. Like you guys have no idea. But we're going to learn just one of them today. And this is what we call factoring out the greatest common factor. Okay? So let's start, although we just did this, by reminding ourselves what we just talked about. Okay? If I want to go this direction, where I have 2x times 3x plus 4, okay, you would distribute the 2x. 2x times 3x, 2 times 3 would give you 6, x times x would give you x squared, and then 2x times 4 would give you 8x. That direction is multiplying. That's what we just did. When you distribute, you are multiplying. What we're going to do with this, we are going to go back the other way. So like I said, if I asked you to factor 6x squared plus 8x, I'm asking you the same thing as if I said factor 12. What can you multiply together to give you 12? What I would be saying is, what can you multiply together to give you 6x squared plus 8x? This direction, going back the other way, is called factoring. Okay, factoring. What can you multiply together? So, the big thing, and I'm going to say this so many times for this chapter, when I ask you to factor something, your answer should be a multiplication problem. Because that's what I'm asking you to do. What can you multiply together? What times what? Multiplying. Okay? So to do this, to factor out the greatest common factor, one way you can think about it, you factor it by undistributing. Because that's what we did, right? If I want to turn it back into something like this, what I'm trying to do is I'm trying to turn it into a distributive property problem. So there's two parts to the distributive property problem. There's the thing out front and then the thing in the parentheses. So the first thing you have to do is find the thing that's out front. Now it turns out that that thing out front that you distribute is the greatest common factor. Maybe it's been a while since we've done the greatest common factor. Okay, we'll talk about how to find the greatest common factor. So the greatest common factor is going to go in front of the parentheses. That's what you would have distributed. Then what you're going to do is you're going to kind of in your mind say, okay, if I were to distribute that greatest common factor, what would I need to distribute it to in order to give me that original answer back? Okay, so let's just look through a couple of these. Let's remind ourselves again what we just talked about. I know it seems kind of silly, but let's start here. I'm going to write something because I really want you guys understanding the difference between factored version and distributed version. So something that is factored might be something like 3a times a plus 4. Because if it's a factored version, if something is factored, it's a multiplication problem. And that's what this is, 3a times a plus 4. If you wanted to turn this into a distributed version, you would just distribute 3, like we just did. You would take 3a times a, which would be 3a squared, and you would take 3a times 4. 3 times 4 is 12, and then we have the a. Now what we're doing today, we're going to go back the other direction. So let me show you something that's the distributed version and see if we can factor it. So let's say we have 4x squared minus 8x. Okay, what I want to do here, I want to turn this into a distributive property problem. So there's two things you need to find, okay? Your answer is going to look something like this. It's going to be something times something in parentheses. What I want to know is I want to know what would I have to distribute into these parentheses to give me 4x squared minus 8x. So the first thing you need to find is what's going to go on the outside. What's going to go on the outside is going to be the greatest common factor. Now, another way to think about the greatest common factor, you're looking for the biggest number that you could evenly divide out of 4 and 8. There's a couple things. I could divide each of those by 2, right? 4 divided by 2 and 8 divided by 2. Is there something else I could divide out of 4 and 8? Something bigger than 2? You do 4, right? 4 divided by 4 and 8 divided by 4. So the number part of my greatest common factor that's going to go on the outside is going to be a 4. Now here's the thing. I need to, this is called factoring out. I need to factor out anything they have in common. Anything they have in common. Now they have a 4 because you can divide out a 4. But if you look at these, what else do they have in common? And x. Now here's the thing. You want to factor out as much as you possibly can. But here's the thing. When you factor it out when it comes to the variables, how I think about this, it's like you're taking it away. So what you want to do is you want to take away as many as you possibly can, but you have to take the same amount from both of these. So the x squared, there's 2 of them here, but there's only 1 here, right? So you can only take 1. Does that make sense? So what you're going to factor out is a 4x. Now, remember, your answer is something times something. Your answer is going to be 4x times something. What you need to figure out is what would I distribute this 4x to give me this? So think about the distributive property. 4x times what would give me 4x squared? 1x. Right? And then do the same thing. 4x times what would give me negative 8x. A negative 2. See, 4x times x is 4x squared. 4x times minus 2 is a negative 8x. That's the second part of what we're doing today. Okay, let's do one more of those and then we'll move on to examples for today. Okay, so let's do 25x squared minus 10x plus 15. Okay, so if I were to ask you to factor this, I'm asking you, what could I multiply together to give me 25x squared minus 10x plus 15? I'm asking you, what distributive property problem would give me that? Okay, so the first thing I need to figure out, okay, what's going to go on the outside? So I need to figure out, what could I factor out, or what could I divide out, let's start with the numbers, of all of these numbers? 5. See that? 25, 10, and 15, so 5. Now here's the thing. You want to factor out as much as you possibly can. So, if I can, I would also like to factor out x's. But here's the thing. If you factor it out, it's like you're taking it away. So I could take an x squared from that first term, and x from the second term, but see how that third term? It doesn't have any x's. So if you were to try to factor out an x, that last term doesn't have any x's to factor out, so you cannot factor it out. Does that make sense? So we're only going to factor out a 5. Now, to figure out what's going to go on the inside, we'd say, okay, 5 times what would give you 25x squared? 5x squared. And then 5 times what would give you negative 10x minus 2x. And then 5 times what would give you a plus 15. That's factoring. That's the factoring we're doing today. Okay? Alright, so here's what I would like you guys to do. I'd like you to get these just glued like one on top of the other. You're going to glue them onto page 17. And we'll call this section 8-2, and it is going to be multiplying and factoring. So let's start with the multiplying direction. So number 1, let's start simple. If I have 4 times 3x minus 5. Okay, to multiply these together, you're just going to distribute. And remember, whenever we distribute, we're multiplying. You would take 4 times 3x, which is 12x. And then you would take 4 times minus 5, which is a minus 20. When you're multiplying, it's hits. So like I said, in some ways, this isn't really any different than a lot of things we've done already this year. What's different is you might have something like this. It might say 5x times 2x plus 1. And the only difference here, so you have to remember those exponent rules. Now, the concept is still the same. You're going to take 5x times 2x. So I would just, especially while we're getting used to this, just take it really slow. Take 5 times 2, which is 10. And then do the x's. X times x is x squared. And don't forget to distribute to the second one. 5x times 1, anything times 1, just going to stay itself. It's going to stay a plus 5x. Okay, number 3. 6xy squared times 3x squared minus 2x plus 7. So a little more intense, but it's the same thing. You're going to distribute, multiply that 6xy squared times all 3 of these terms. So take it step by step. Do the numbers first. 6 times 3 is 18. Do the x's. X times x squared would be x cubed. And don't forget, we do have that y squared. There's no other y's to kind of combine in there, but you do still have to put the y squared there. Okay? Then we're going to take 6xy squared times a negative 2x. So do the numbers first. 6 times negative 2 is negative 12. X times x is x squared. And we still have the y squared. And then lastly, 6xy squared times 7. You would take 6 times 7, which is 42. And then we still have the xy squared. No other variables to add into there. Is this making sense? Let's try number 4. Okay, negative 8x squared y cubed times 4x squared minus 5xy minus 6y squared. So these aren't difficult, but you do just have to take them really slow. Okay? When you distribute first, do the numbers first. Negative 8 times 4 is negative 32. Do the x's. X squared times x squared would be x to the 4th. And then we just have the y cubed. Okay, distribute to the middle term. Do the numbers. Negative 8 times negative 5 is a plus 40. X squared times x would be an x cubed. Now y cubed times y would be a y to the 4th. And then lastly, do the numbers. Negative 8 times negative 6 gives me a positive 48. X squared, no other x's to include in that one. And then I have my y cubed and y squared, which gives me a y to the 5th. Okay, let's do one more together, and then I'll have you try the last one of the distributive property on your own. So number 5, okay, let's do negative x cubed y cubed times 4x to the 5th minus 3x cubed y plus 4. Now, if it helps, I would encourage you, just write that 1, it's negative 1. That way you don't forget about it, because when you're distributing, you're going to take negative 1 times 4, which is negative 4. And then you're going to take x cubed times x to the 5th, so 3 plus 5 will give you x to the 8th, and then you still have the y cubed. Okay, we're going to take negative 1 times negative 3, which is a positive 3, x cubed times x cubed, 3 plus 3 would give you x to the 6th. Y cubed times y should be a y to the 4th. And then lastly, negative 1 times 4 would be a minus 4, and then we just have the x cubed, y cubed. Okay, I'll have you guys try number 6 on your own, and then we will move on to the factoring. So number 6, I want you guys to try 10x to the 4th, y to the 5th, times 5x cubed y plus 4x squared y squared minus 3x squared y cubed. Okay, let's see how we did. So you really have to take this one slowly. So 10 times 5 would be 50. X to the 4th times x cubed should be x to the 7th. Y to the 5th times y would be y to the 6th. Okay, for the second term, 10 times 4 would be 40. X to the 4th times x squared would be x to the 6th. Y to the 5th times y squared would be y to the 7th. And then lastly, 10 times negative 3 would be negative 30. X to the 4th times x squared would be x to the 6th. And then y to the 5th times y cubed should be y to the 8th. Okay, how are we feeling about the multiplying? Okay, now remember, the factoring, guys, you're just going back the opposite way. You're doing the opposite of what we just did. You're going to undistribute, okay? So let's try this one. So these ones we are going to factor. So remember, anytime I say factor, I'm saying, what could you multiply together to give me So for the first one, let's do x squared minus 5x. So if I'm asking you to factor something, I'm asking you, what could you multiply together to give you x squared minus 5x? Well, here's the thing. X squared minus 5x is the answer to a distributive property problem. I mean, that's what it looks like, right? So your answer is going to be that distributive property problem. You've got to figure out what would you have to distribute into those parentheses to give you x squared minus 5x. So what's going to go on the outside is what you would have distributed, which is the greatest common factor. Now, if you're looking at x squared minus 5x, they really don't have a whole lot in common. But they do both have an x. See that? So what you're going to do, well, you would have distributed an x. Now, to get this, you'd have to say, okay, well, x times what would have given you that x squared? X times x. And then x times what would give you negative 5x minus 5. You can always check your answers for these ones, right? X times x squared, x times minus 5. Oh, that one. That was your answer. That is your answer. Okay. Let's try 20x squared plus 35x. So remember, if I'm asking you to factor, I'm asking you what could you multiply together to give you this. Okay? So, what would you distribute to what to give you 20x squared plus 35x? Okay? Now, let's figure out what would have been on the outside of the parentheses, which is going to be the greatest common factor. So the number-wise, what you're looking for, I'm looking for the biggest number that I could evenly divide from 20 and 35. 5, right? Okay, so it's going to be a 5. Then you're going to look at the variables. And remember, you want to factor out as many variables as you possibly can, right? So I would like to factor out an x squared, right? Because I could take an x squared from that first term. But you see the second term? It just got 1. I can't take an x squared. It doesn't have an x squared. So you can only take out an x. So you're going to factor out a 5x. And then think about the distributive property. 5x times what would give you 20x squared? 4x. 5x times what would give you 35x plus 7. Okay, this is the factoring part. See, I told you guys, it's so fun, isn't it? I know, it's so fun. Okay. Number 9. Let's do 3x cubed plus 6x squared plus 9x. Okay, so you already know what your answer is going to look like. Your answer is going to look like a multiplication problem, a distributive property problem. The first thing you need to find is what would go on the outside. So start with your numbers. I have 3, 6, and 9. I'm looking for the biggest number that I could divide out of all of those. What would it be? Just a 3. And then look at the variables. I have an x cubed, an x squared, and an x. How many x's do they all have in common? Just 1. Right? Because if you try to take out more than 1, that term right there, it doesn't have more than 1 to give. So you're just going to factor out a 3x. So 3x times what would give you 3x cubed? So 1 x squared. What I kind of think about for the variables, when you're factoring out an x, it's kind of like you're taking 1 away. So if you had an x cubed, you factored out or you took away an x, so an x squared left, if that helps. Okay? 3x times what gives you 6x squared. Right? Because we had an x squared, I factored 1 out, got 1 left. And then 3x times what gives you 9x. Okay, close to it, right? This had an x, but I factored it out, so there's none left there. Okay, number 10. Let's do x cubed y squared minus 4xy squared. Okay, first thing, you know your answer is going to look like this, so I need to first figure out what's going to go on the outside. So number-wise, What can I evenly divide out of both of these? Oh, yeah, 1. Right? This doesn't have a number, so I'm not going to factor out any number. If you want to write a 1, you definitely can. Now let's look at the x's because I have 2 variables here. I have an x cubed and an x. How many x's could you take? Just 1, right? Now I have a y squared and a y squared. How many y's could you take? You could take 2. See how they both have a y squared? So what we're going to do is we're going to factor out an x y squared. So for this first term, I had an x cubed. If I factored out an x, how many x's are left? X squared. I had y squared. I factored out y squared. Any y's left? Okay. Now the 4, I didn't do anything with the 4, so the 4 is going to stay there. I had an x. I factored out an x. No x's left in that term. I had a y squared. I factored out a y squared. No y's left either. So your answer would just be xy squared times x squared minus 4. Is this making sense? Okay, let's do 2 more. Okay, number 11. Right, I did this on number 5 in my notes. Okay, 14x cubed y squared minus 21x squared y cubed. Come on, you guys do this one in pieces, okay? The first thing I want you to do, go ahead and sign up your parentheses. I want to see if you can come up with what's going to go on the outside. Take a second, see if you can figure out what your greatest common factor is going to be and get it written down. So number-wise, between 14 and 21, what's the greatest common factor? 7. X cubed and x squared. How many x's do they have in common? X squared. Y squared, y cubed. How many y's do they have in common? 2, right? Remember, you want to take as many as you can, but you have to take the same amount from all piles. Okay, to figure out what goes on the inside, 7 times what gives you 14? 2. I had an x cubed. I factored out an x squared. So there's an x left. I had y squared, but I factored it out. Okay, 7 times what gives me a minus 21? Minus 3. I had x squared, but I factored it out. I had y cubed. I factored out y squared. What else is left? A y. Okay, you guys want to try the last one on your own? Okay, let's have you try this last one on your own. Let's do 40x cubed y minus 16x squared y squared minus 24x y squared. I did see a couple correct answers, and I think the ones that didn't have the correct answer were super close. Now remember, whenever you're looking for the greatest common factor, so what's going to go on the outside, you want to find the biggest number that you can divide out of 40, 16, and 24. The incorrect answers I saw had 4, which is a common factor. But there's something bigger. They have an 8 in common. Okay? So we're going to factor out an 8. Now, if you look at the x's, there's 3 things to look at. We have x cubed, x squared, and an x. How many x's do all of those have in common? Just an x, yep. And then I have y, y squared, y squared. Yeah, just 1. So it's going to be 8xy. And then, if it helps to take it in pieces, it'd be 8 times 5, x times x squared. And then the y, you wouldn't need a y there because we factored it out. 8 times minus 2, x times x, y times y. And then 8 times a minus 3. The x I factored out, and then y times y, you would have a y left there.